Question number 1. Construct a suitable scale in which a line measuring 10 mm represents a length of 2.5 meter. Taking the measurements from the scale constructed, prepare a neat scale diagram of a quadrilateral ABCD. In the same diagram, draw a triangle PAB so that the area of triangle PAB is equal to area of quadrilateral ABCD. All necessary calculations to be shown neatly. Given in quadrilateral ABCD, AB is equal to 24.8 meter, BC is equal to 17 meter, AD is equal to 10.3 meter, angle ABC is equal to 45 degree, angle DAB is equal to 60 degree.
So first we will see given data. So that is drawing length equals to 10 mm, actual length is 2.5 meter, AB equals to 24.8 meter, BC equals to 17 meter, AD equals to 10.3 meter, and angle ABC is 45 degree and angle DAB is equal to 60 degree. So now what we will do first? First we will write the formula that length of scale is equal to RF into ml. Now what is RF? RF is representative fraction. So representative fraction equals to drawing length upon actual length, right? That is drawing length upon actual length. So if I want to find out RF is equal to how much is drawing length? 10 millimeter, right? And how much is actual length? 2.5 meter. So that is equal to 10 upon 2500. So that is 1 upon 250 is RF, right? After that, what we can do? We can draw few more guidelines. Now we'll apply this formula. What is length of scale is equal to LS, right? If I write in short form, so length of scale is equal to RF into ml. Now ml. What is ml in this? Now if you see, maximum length is 24.8, 17 and 10.3. So this is maximum length. So what we will do? Round off 30. So ml, this is equals to maximum length so we'll put this. We know RF is how much? 1 upon 250. Maximum length we will take 30, right? We will take 30 meter. Multiply by 100 will give me centimeter. Now if I'll solve this, I will get this will go. So we'll have 300 upon 25. So roundabout we'll have 12 centimeter. So our length of scale equals to how much? 12 centimeter. Okay, so now we will draw 12 centimeter long line and we'll take height 5 centimeter. See, we can take this height whatever we want. At times people take 3 centimeter, 5 centimeter. So I'm taking 5 centimeter. So I'm taking 5 centimeter. Now if you see, this is how much long? This is 30 meter long. So we'll divide this into how many parts? 3 parts. So we'll draw inclination and we'll cut 1, 2, 3. So we'll divide this line 12 centimeter into 3 parts. So we got 0, 10, 20. This is meter. And this is also meter. So I'm dividing 30 into 3 parts, 10, 10, 10 meter each. Now we need to divide this first block into 10 parts. So we'll take one more angle. See, preferably we take this 30 and this 30 and this is at 45 degree. So from here we'll take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 equal arcs. Join this to this and then draw a parallel line. So we're dividing this line into 10 parts. Then we'll mark this point down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we won't be drawing straight line, but we will be just marking the point. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now see this, we need to mark 24.8, 17, 10.3. So we need decimeter also. So we'll divide this 1 meter into 10 equal parts. So what we will do for that? See, first we will name this point 1, 2, 3. Then we'll join 0 to 1. We'll join. Then we'll join 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6, 6 to 7, 7 to 8, 8 to 9, and 9 to 10. And this we have taken 5 centimeters. So we'll divide this into 10 parts. So we can do this directly. We'll mark 5 mm each. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? See this. So we got this decimeter. And we need to write RF over here. RF is how much? 1 upon 250. Right? So now if you want to see this is 1 decimeter, this is 2 decimeter, this is 3 decimeter, this is 4 decimeter, 5 decimeter, 6 decimeter, 7, 8, 9 decimeter, and then 1 meter. So that way we have divided this 1 meter into 10 parts. This will be done. If you want, you can extend these lines also. This line also you can extend over there. Now we will see marking. So now for quadrilateral ABCD, we want AB to 24.8. So how we will mark 24.8? We'll take 20 from here. Then we'll take 1, 2, 3, 4. Right? So it is 24. Then 1, 2, 3, 4, 5, 6, 7, 8. So from this point to this point, this is 24.8. I can name this AB. So we have marked AB 24.8. So this is 24.8 meter. Then BC is 17. So from here we take 10, then 1, 2, 3, 4, 5, 6, 7. So now we have BC, which is 17 meter, right? Then we have AD 10.3. So we have 10, then 1, 2, and 3. So we have AD, which is 10.3 meter. First we will draw 12 centimeter long line. We'll divide into 3 parts. Why? Because it is 30. Then we'll divide the first block into 10 parts. So we will get 1 meter each. Then we'll divide that 1 meter into 10 parts. So we will get decimeter, and then we will mark respective points. So now we have side AB 24.8, BC 17 meter, AD 10.3 meter, angle ABC 45, and DAB 60 degrees. So first we will draw quadrilateral. So what we will do? First we will draw side AB, which is 24.8, right? After that, they have given angle DAB 60 degrees. So I will draw 60 degree, and they have given angle ABC 45. So then we will draw 45 degree. Okay, after this we'll mark BC is how much? 17. So it will be here somewhere. And AD is how much? 10.3. So D will come here. So then we will join this. So we got this quadrilateral. Now what we need to do? We need to convert this quadrilateral into triangle PAB. So what we will do first? First we will draw a diagonal. Then we will draw a parallel line passing through C. See, we will join BD. Then we will draw a line passing through C. Then we will extend this. So wherever it will cut, see this. So what we are doing, instead of triangle BCD, we are going for triangle B. See, instead of BCD, we are going for triangle BPD. See this. So instead of BCD, we have triangle BPD according to equal area theorem. So we can write area of triangle PAB equals to area of quadrilateral ABCD.